Now we are going to trigonometric ratios of special angles. Now, what are the special angles that we are talking about here? We'll be talking about angle 30 degree, 60 degree, then we have 45 degree. We also have 90 degree, but we call them special angles because these angles we can generate them without making use of four-figure table. That's why we call them special angles. And over the years, I've seen students cramming these things, but there are things that you can quickly derive. Even if you find yourself in an examination hall, you can quickly derive them without going through too much stress at all. So I'll first look at the one for 30 degree and 60 degree. To derive the trig ratios for 30 degree and 60 degree, we make use of what we call an equilateral triangle. What do we call an equilateral triangle? An equilateral triangle is a triangle having all its sides and all its angles to be equal. Now for this triangle we have three angles, and sum of angles in the triangle is 180 degree. So if you divide the 180 degree by 3, that will give us 60 degree. So which means this angle A is 60 degree, this angle A is 60 degree, this angle A is 60 degree. So I will label this one as capital A, capital B, and capital C. Now from A, the sides, I said it the other time that for an equilateral triangle, all sides are equal, while all angles are also equal. So we use 2 units from A. This one 2, and this one 2. But for the other one, for 45 degree, which we are still going to derive later, instead of using 2 for 45 degree, we use 1 unit each. So from A, the next thing to do from A is to get a means of bringing out a right angle triangle from A, so that the trig ratios that we have learned can be applicable A. Then how do we do that? We divide this angle. There is a perpendicular bisector that divides this angle into 2 equal parts. So dividing that angle into 2 equal parts, this one will be 30 degree and this one will be 30 degree. We can as well divide any other angle. It is not a must that we divide angle A alone. We can as well divide this angle C. We also have something like that. We can as well divide angle B alone instead of dividing A. And the reason why we divided A is for us to be able to bring out 30 degree. Because the triangle initially was only talking about 60 degree. So to have 30 degree, we divide that angle into 2. So as that perpendicular bisector is dividing this angle into 2 equal halves, it will also divide this side into 2 equal halves too. The addition of 1 and 1 will still give us these 2 that we had earlier. So this one now is a right angle and this one is a right angle. Now from A, we need to ask ourselves that, okay, after dividing this angle into 2 equal parts and dividing this side also into 2 equal parts, then what is the height of this particular triangle? Then that will take us back to this. We bring out a triangle. We can bring out this one or we can bring out this other one. The two of them, they are the same thing. And when we have triangles that are the same thing, we call them similar triangles. So when all their sides, since this one is 30, this one is 30, this one is 60, this one is 60, this one is 90 for this one is also 90 for this one. So this is 2, this one is 2. The base of this one is 1 and the base of this one also is 1. So that's why they are called similar triangles. So this one is 2, this one is 1, and this angle A is 60, while this angle A is 30. This one too, the angle A is 30, the angle A is 90, and the angle A is 60. So why this one is 2 and this one is 1? So we can use this and we can use this, as I said earlier. So from A, the next thing we do is to get this. We represent this one with any alphabet of our choice. And by using Pythagoras theorem again, we have the longest side, which is the side facing our right angle. that is the longest side, which is the hypotenuse side. So we have 2 raised to the power 2 is equal to 1 square plus y square. That will give us 4 is equal to 1 plus y square. Since 1 square is the same thing as 1, whatever we divide by 1 will also give us that value, that number, and if you multiply 1 with any number, it will remain unchanged. So from here, the next thing we do is to take 4a to collect like terms. So we have y square is equal to 4 minus 1. So when we have 1 like this, it is the same thing as plus 1. So we have y squared to be equal to 3. And the next thing to do is to take the square root of both sides. Since 3 is not a perfect square, so what we just have there is that y is equal to square root of 3. The perfect squares that we have, they are 1, 4, 9, 16, 25, 36, and so on. They are perfect squares that we have. So this one, if you should take the square root without calculator, there's nothing we can do. Or if you don't have calculator or 4-figure table, we cannot get this. So it's better we leave it as root 3 over 2. So since we call them special angles, so this one is root 3. And now the next thing is to now derive the trig value for sine 30, cos 30, tan 30, sine 60, cos 60, tan 60. And these are useful if you are trying to solve a question and there is an instruction in the question that we should get our answer without using calculator or 4-figure table. And we don't need to cram it. With this simple way, we can quickly derive them if you are in an exam hall. So from here to 60 degree now, the side facing it is opposite. But let me even do the one for 30 first. From there we have sine 30. Sine 30 is opposite over hypotenuse. And the opposite over hypotenuse is still from our so. So this is 30 degree. The side facing 30 is what? That is 1. And the hypotenuse side, which is the side facing the right angle, is 2. That's why for this one, if we should use calculator or we should use 4-figure table, this one will give us 0.5. But if you come across the question giving us the instruction that we should not use calculator, this is what we use, 1 over 2. Because in WAEC or any examination, once there is an instruction like that, if you should go ahead to use calculator, we will know. And even if you end up having the final answer, the right answer at the end of the day, the fact that you have violated the rule, you are asked not to use calculator. If you have used calculator and you have the right answer, you won't get any mark for that. So you have to go through this. From there also, we have cos 30 degree. Cos 30, that is adjacent over hypotenuse. We are still making use of our 30. I said this is opposite because it is the side facing 30. So this is hypotenuse because it is the side facing our right angle. So the last side is what we call hypotenuse, the adjacent. That is root 3. And the hypotenuse is 2. This one is root 3 over 2. If you should press your calculator, it will give you 0.8660. So where you are to write root 3 over 2, if you should make use of root 0.8660, you will get the right answer, but you will not get your mark for it. So stick to the instruction that you have in the question. It's always good. So from there, the last one we have there, we have tan 30 degree. That is opposite over adjacent. And if you look at 30 degree that we have, our opposite side is 1. Then our adjacent side is root 3. So these are the special angles for 30 degree. So apart from 30 degree, we also have for 60 degree. We also go through the same process. But instead of using 30 this time around, we go to 60. We have sine 60 degree. That is also opposite over hypotenuse. Now to 60 degree now, this is no more our opposite because we have changed from 30 to 60. To 60 degree now, this will now serve as our opposite, and the longest side still remains the hypotenuse. So this one will give us root 3, since the opposite of 60 is root 3 over 2. Then from there we have cos 60 degree. That cosine from car, that is adjacent over hypotenuse. The adjacent side now to 60 degree is 1. So that is 1. The side facing it happen to be opposite, so the other side is adjacent, and our hypotenuse still remain 2. Then lastly, there we have tan 60 degree to be opposite over adjacent. And what is the opposite side of 60? That is root 3. And what's the adjacent side? That is 1. So this is root 3 over 1. If you divide anything by 1, we still have that value without changing. So I hope this is well understood, and we can look at the other one too for 45 degrees. So these are the special angles that we have, and there are things that we can derive in an exam hall without even cramming or going through too much stress. Now for 60 degrees the other time, we used an equilateral triangle. This time around, we want to derive for 45 degrees. Here we make use of isosceles triangle. And what do we mean by isosceles triangle? A triangle is isosceles if the base angles, if they are equal. Now if I should draw something like this, and this place is 90, I'm assuming that this is the altitude of this triangle. Altitude of the triangle is just the top. So these two now, they are the base, and base angles are equal. So since again we know that the sum of angles in a triangle is 180, so if 90 is out of 180, we'll be left with 90. So if we divide that 90 degree by 2, you have 45. We divided by 2 because we are looking at two angles here, so that's where the 2 is coming from. So this will be 45, and this will be 45 degrees. So I will label this one A, I will label this one B, and I will label this one C. Since the base angles are equal for an isosceles triangle, then the base sides, the sides there, they are also equal. So we use 1, 1 here. Instead of the other one that we derived the other time, we use 2, 2. And when we add the perpendicular bisector that bisected one of the angles, it's divided them into 1, 1. So that's where the 1, 1A is coming from. So from here, I will denote this one with X. And this is a right angle triangle. So when we have a triangle and we don't know what the sides are, especially for a right angle triangle, we now go back to the work of Pythagoras, and we use Pythagoras theorem. So using Pythagoras theorem, the longest side, which is the side facing our right angle, we have denoted that one with X. We have X squared is equal to the square of the other sides, 1 square plus 1 square. So X squared from there will give us 1. 1 square is 1, and 1 square is also 1. So which means from there, X squared will give us 2. And if you find the square root of both sides, 2 is not a perfect square as well. The same way 3 was not a perfect square the other time, 2 is not a perfect square, and the square does not exist. But it exists if you use calculator or we use 4-figure table. But without those two, we just leave our answer as x is equal to square root of 2. So in place of this one, this will be square root of 2. So after deriving this x to be root 2, now from there the next thing we do is to generate sine 45 degree. We can use this 45. If you are using this 45, the opposite side is 1. If you are using this 45 too, the opposite side is also 1. So we can use any of the two. So from here, sine 45 is opposite over hypotenuse. And our opposite is 1, while our hypotenuse is root 2. Also for cos 45 degree, we have adjacent divided by hypotenuse. If you are using this one as our opposite side, if you are using this 45, this is opposite and this is adjacent. So that is 1/2. But if you notice something here, we notice that the value of sine 45 and cos 45, they are the same thing. The reason is the two angles, 45 and 45, two angles are set, they are the same thing. The sine and cosine are the same thing if their sum is giving us 90 degrees. And we call them complementary angles. So the same thing also for the previous one. If you observe what we obtained in the previous one, we notice that the value of sine 30 and cos 60, they are the same thing. Because if you have 30 and 60, we have 90 degrees. So the same thing is occurring here. And for the last one, we have tan 45 degree to be opposite over adjacent. So our opposite is 1, then our adjacent is also 1, and 1/1 is 1. So these are the special angles that we have. And the other one that we have sine 0 is equal to 0, cos 0 is equal to 1, then we have tan 0 is equal to 0. Tan from here, tan is simply sine over cos. That's what tan is. So if you divide 0 by 1, we have 0. That's why this tan is giving us 0. Then the last one that we have, that is sine 90 degree. Sine 90 is 1. Cos 90 degree is 0. Then tan 90, it does not exist. Even if you use calculator, if you divide any number by 0, the calculator will give us mathematical error, just because that thing does not exist. And at times they will want to test our knowledge, and they will ask us that, okay, tan 90 is, then they write the options, they write 0, they write 1 divided by root 2, they write root 2 over 1, and they write infinity. When something does not exist, we denote it with this symbol, that is infinity. So if you are not careful enough, we just go ahead and pick 0, which is the wrong answer. So tan 90 does not exist, but we assume it exists, and that's why we represent it with this symbol, which is infinity. So even in the graph, if you are trying to plot the graph too, when we are plotting tan graph, we get to a point when we have 90 degrees, the graph will be discontinuous. It will not have any value. So we have other ones too that doesn't exist too, like 180. Tan of 180 does not exist. Tan of 270, it does not exist too. But these are the basic ones. So if you know these ones, those ones, they are other things. So these are the basis of what we have here. So this will lead us to an example, which we are going to solve now to check, to apply these things that we just derived now. So now we have this example to solve, and the question says, when one end of a ladder LM. So for a ladder, we have the top and we have the base. So I'm using this as an example. Let's assume that this is our ladder. We have this as the top and we have this as the base. It's placed against a vertical wall. Let's assume that this is our vertical wall and this is the horizontal ground. The ladder is placed against the vertical wall at a point 5 meters above the ground. That is, the point where the top of the ladder is touching is 5 meters from the horizontal ground, like this. Now the ladder makes an angle of 45 degrees with the horizontal ground. The angle between the base of the ladder and this horizontal ground, the angle A, is what we are given as that 45 degrees. The A part says we should represent the information in a diagram. And the diagram we are using now is the length of this ladder, the distance from A to the base of the wall, and the height above, the height below the point where the ladder is touching the wall. So for that, we have this right angle triangle. This is the wall, this is the horizontal ground, and this is the ladder. So this one we are given as 45 degrees. That is the angle that the ladder is making with the horizontal ground, and this is the right angle because the wall is perpendicular, is at right angle to the horizontal ground. And we are given also that the ladder is touching the wall at a point 5 meters above the ground. And the question we have here is to calculate in surd form. So when we see in surd form, that means we have to make use of those special angles that we derive instead of using our calculator or our 4-figure table. And those things, as I explained earlier, I said there are things we can quickly derive drawing our triangle. So since this one is talking about 45, we just quickly draw our right angle triangle to generate what the sine or cosine or tangent of 45 will be. So this is what they are asking us to find now. I will label that one as y. So this is 45 degrees, which is the angle we are talking about. So this side is the opposite side. The longest side, which is representing the ladder, is the hypotenuse side. And the last side, which is representing the horizontal ground, is labeled as adjacent side. So when we want to make use of all these SOHCAHTOA, at times, we combine what we have with what we are looking for. The question is not asking us to calculate the distance from the base of the ladder to the base of the wall. The only thing we are asked to find here is to find the length of the ladder. So which means we are asked to find this one and we are given this one. So we combine the two and that will lead us to the second one. So we have the one we are given, we know opposite and we are looking for hypotenuse. So opposite over hypotenuse is taking us back to so, and this S here is representing sine theta. So theta here is 45 degrees, which is talking about the angle we are given. So we have sine 45 degrees is equal to opposite is 5, then hypotenuse from there is y. So this sine 45, we can also write it, but we don't need to do that. So from here, what we do is that we cross multiply. By cross multiplying, we have y sine 45 is equal to 5. By cross multiplying, this one we multiply this, then this one we multiply an invisible one that we have here, because if you divide sine 45 by 1, we are still going to have this, we are still going to have it as sine 45. So if we multiply 1 by 5, we still have our 5 from there. There is another way of doing it apart from cross multiplying first. Instead of cross multiplying first, we can just put this value, since we have derived earlier the value of sine 45 as 1 over root 2, then this will just be 5 over 1. And at this point, we can cross multiply. So if you do that here, we have y is equal to 5 root 2 centimeters. And that is given. Therefore, length of the ladder is equal to 5 root 2 centimeters. We are leaving our answer in this form because of the instruction we have here, that we should calculate in surd form the length of the ladder. I got a question asking me for the meaning of surd. Surd generally is the square root of prime numbers. And I explained what we mean by prime numbers earlier, that prime numbers are numbers that can be divided by 1 and itself. So when we see root 2, this is a surd. When we see root 3, it is a surd. When we see root 5, is a surd. Generally, surds are irrational numbers. And irrational numbers are numbers that cannot be expressed as ratio. Ratio is just, if you have something like 2/3, this is fraction, and we can also call it 2:3. But these ones, they cannot be, root 2 cannot be expressed as a ratio. So it is an irrational number, and irrational numbers generally they are referred to as surd. It is different from this if you have root 4. Root 4 does not have any other value apart from what? 2. And 2 can be expressed as 2/1. And 2/1 can be expressed as 2:1. But this does not exist for root 2, does not exist for root 3, for root 5, for root 7, root 10, and so on. So that is where this, and this root 2 that we have here, this 1/√2, we derive it the other time when we are trying to get the special angle for 45 degrees. So that is where that root 2 is coming from, and we call it a surd because it doesn't have an exact answer. And it doesn't have an exact answer because I may use calculator to find root 2 and I write my answer as 1.4. Someone else may write his own answer as 1.41. Someone may write it as 1.41, then another number like that. So it doesn't have an exact answer. But root 4, there's no answer to root 4 than 2.